Okay, time for part 2 of 3.5. We're finally going to get to an example where we put together everything that was talked about in 3.2 as well as all the stuff that we learned in the first video of 3.5. So what we want to do in this problem is follow all of the steps over here on the right under scratch paper. We want to check for symmetry, then find all the real zeros, determine the behavior at the x-intercepts, determine the end behavior, or what x does as, or what y does as x goes to infinity and negative infinity, and then calculate a couple of other ordered pairs. Then we're going to draw our graph. So, first of all, we need to check for symmetry. So step number 1 means substitute in a negative x everywhere there's an x. There's supposed to be a little square right there. Okay, if you cube a negative, you get a negative. If you square a negative, you get a positive, and a positive times a negative is a negative. That's supposed to be times negative x. So negative x times positive 7 will be negative 7x. So now we compare this to the original. Is it exactly the same? It's not. And is it exactly opposite? It's not that either, is it? So this just means it's not symmetrical. So step number 2 says find all the real zeros. Step number 2 is everything that we did in 3.2. That's what we did in that section. So if you're confused, go back and have a look at 3.2. So to find all the zeros, the first thing we have to do is find our p's and q's. So remember, p is your constant term. Q is your leading coefficient. Find all the factors of p. That's going to be positive and negative 1 and 3. All the factors of q, well, that's just 1. So then find your p's over q's. These are all your possible real zeros. So then you do plus or minus 1 over 1 and 3 over 1. So we have a pretty short list this time. Now what we're going to do is test each of these to see which one works. So I'm just going to let the video run while I test them. I do one in my calculator, 1 stow x enter, and then I type in x cubed minus 5x squared plus 7x minus 3. Oh, the very first one I try works. So we find out that f of 1 actually gives us 0. Since 1 gives us 0, we stop and we do synthetic division. Put our leading coefficients in the inside, so we have 1, negative 5, 7, negative 3. You bring down the first one, multiply, add, multiply, add, multiply, add. Now we want to write it in factored form. So the number that gave us our 0 is 1, so we're going to have x minus that number. Then we have this one. Remember, you reduce your leading coefficient by 1, so this becomes x squared and this becomes x. So you have x squared minus 4x plus 3. Then you want to find factors of 3 that add up to negative 4. So we have x minus 1 and 2 more factors. What are factors of 3 that add up to negative 4? So that would be negative 1 and negative 3, right? And remember, you could actually write that as f of x is equal to x minus 1 squared times x minus 3. This is completely factored here. This is the completely factored form. So now we have to find all the zeros. Well, the zeros are x minus 1 equals 0, x minus 3 equals 0. So the zeros are x equals 1 and 3. These are our zeros. So now we have step number 3. And step number 3 says, what is the behavior of the graph at the x-intercepts? So the x-intercepts are, from our zeros, 1, 0, and 3, 0. Well, at 1, 0, the exponent on the factor corresponding to that x-intercept is 2. That's even. That means the graph will touch the x-axis at 1, 0. And what will it do at 3, 0? The factor that corresponds to that intercept is x minus 3, and it has an odd exponent. That means it will cross at 3, 0. This is the behavior of the graph at the x-intercepts. Finally, we want to determine what will happen as x gets bigger and as x gets smaller. That's step number 4. Well, remember, this is a cubed function, so it has this general shape, right? So as x is getting bigger, if you need to, you can draw your little xy in there. As x is getting bigger, what's y doing? It's getting bigger. So as x goes to infinity, y also goes to infinity. What about when x is getting smaller? What's y doing? Y is getting smaller. So as x goes to negative infinity, y also goes to negative infinity. So we're only left with one step before we graph it. Step number 5 is to calculate some other ordered pairs. However, I'm okay if all you do is find the y-intercept. How do you find a y-intercept again? You always let x equal 0. So if x is 0, that's 0, that's 0, and that's 0, all you're left with is negative 3. So x equals negative 3. Your y-intercept is 0, negative 3. Alright, now it's time to draw a graph. Let's plot the 3 points we know. We know 1, 0, we know 3, 0, and we know 0, negative 3. Those are all the points that we know. But we do know other things. For example, we know that on the right it's going up, and on the left it's going down. So we could actually just kind of sketch that in there. On the right it's going up, on the left it's going down. We just need to know what's happening in the middle. Well, our touching and crossing is where we determine that. At 1, 0, so at this point, it's going to touch the x-axis. That just means it's coming up, it's touching, and it's going back down. But then somewhere down here, it's going to turn around and go back to 3, 0. And at that point, it's going to cross the x-axis. So it's going to turn around, go back up this direction. So this is just a basic graph of our function. Something like that.